Hello, we are from EKT318 would like to present our mini project from subject Modern Control System entitled Frequency Response of a Robotic Position Control System. Before that, I would like to introduce myself. My name is Nurul Hakimah Hafizan. I will cover on introduction, objectives, and methodology. Introduction. What is control system? Control system is a device or a set of devices which are interconnected to achieve a desired purpose or output. 6 degrees of freedom, known as 6DOF, is the freedom movement of body to change position such as forward or backward, up or down, and left or right. What does 6DOF related to robotic? Well, robotic is the development of machines that can substitute human and replicate human actions. For an example, robot arms refers to the number of single-axis rotational joints in the arm. This related to 6DOF as a robot arm can move forward or backward, up or down, and left or right. Next is the objectives of this mini project are to determine the gain and phase margin. Next is to design a compensator with phase margin of at least 35 degrees and to demonstrate the result by using Scilab. Methodology. There are a few steps to achieve bode plot and phase lag compensation. For the first one is bode plot. We have to replace S domain to J omega. Next, find the magnitude and phase. After that, plot the bode diagram by using Scilab. Next is phase lag compensation. The first thing to do is find the frequency for the new phase margin. Also allow 5 degrees of safety margin for the new phase margin. After that, we can find the gain crossover frequency known as omega c. The reduction of gain is 20 log alpha. From here, we can determine the value of alpha. After that, we can put 0 known as Z 1 decade below. Therefore, Z is equal to gain crossover frequency, which is omega c, over 10. Continue to that, we can find the value of tau from Z, where Z is equal to 1 over tau. Last but not least, rewrite the phase lag network transfer function as Gs equals to 1 plus tau s over 1 plus alpha tau s. That's all from me. I will pass the floor to my friend Mazni to explain detail on how to achieve this method. Thank you.
Hi, my name is Mazni Ramle. Now I want to present about result and discussion of bode plot and phase lag compensation. For the bode plot, first step you have to replace S into J omega. This is our transfer function. K you can replace with 10. And then once you get the J omega, you can get this equation. You have to split into two plots, which are magnitude and the phase plot. In the Scilab, you can get phase margin and the gain margin. First, you have to type this one, and then the numerator, denominator, the transfer function. If you want to find the phase margin, you can use this one. You can type like this one, and then you can get the value of the phase margin. Same goes to the gain margin. If you want to find the gain margin, you can type like this. And press enter, you can get the gain margin, the value of the gain margin. If you want to look for the graph, you can type show underscore margins in bracket TF, and you can get the magnitude graph and the phase graph. Next, for the phase lag compensation, first step, you have to find frequency for new phase margin. In the requirement, phase margin must at least 35 degree, so that you have to plus 35 with 5 degree, which is safety margin, and you can get 40. Once you get 40, you can plus with negative 180, which is the new frequency at phase. Once you get the new frequency at phase, back to the graph, and then you go to the phase graph, you find the negative 140 degree, then you can get the value of the frequency. Then you have to find the gain crossover frequency using this formula. And the value is 4.532 radian per second. In the magnitude graph, you have to find the magnitude in dB. Just now, you just get the frequency 0.7213, so you have to find the frequency in magnitude 0.7213 Hz. Then you can get the value of magnitude in dB. You have to convert the value in dB to unitless using formula 20 log alpha. Then you can get the value of alpha 1.526. After that, you have to find the z equal to omega c over 10. Replace omega c with the value 4.532 per 10, and you can get the value 0.4532. The next step is you have to find the tau using the formula z equal to 1 over tau. Then you can get the value 2.208. Once you get the tau and the alpha, you can rewrite the transfer function phase lag using the equation 1 plus tau s over 1 plus alpha tau s. And this is the equation. Okay, go back to the Scilab. You have to find the system phase margin. First, you have to rewrite the numerator, the denominator. Then you have to write the new numerator and the new denominator. And this is for the transfer function. Then for the system phase margin, you have to type like this. Then you can get the system phase margin, which is the value is 37.862329. That is almost equal to 35 degrees to satisfy the requirement. Lastly, for the conclusion, all in all, lag compensator does not affect the transient response and decreases phase shift. On top of that, lag compensator allows to pass lower frequencies and attenuate higher frequency. Thank you.